So I'm going to show you how to set up one of the electron beam tubes. The beam tube I'm using for this example is a diffraction beam tube. So this is the diffraction beam tube. Okay, so I've got the EHT supply. So this is the EHT supply at the back here. This goes up to 5,000 kilovolts, and then I've got the holder for the beam tube here. When I'm putting the tube in, I'm going to check that these sliding plastic sections are slid to the right, because they will tighten up and grip the beam tube as you move them to the left. So I'm going to have this set up so that this connection is pointing away from me, because that's going to be the anode and that's going to be at high potential. So I'm going to have that pointed away from me, away from anyone walking past. So this just slots in and it will click at the top and bottom. And then to tighten it, I just slide these plastic sections back down and they will grip it. Okay, so there are two circuits within this. There's a high tension, high voltage circuit, and there is a lower voltage circuit. The lower voltage circuit is purely there to heat up the filament. So towards this end of the beam tube, there is a simple filament just like a light bulb, and it lights up like a light bulb, and that is at relatively low voltage, and the point of that is just to get hot. So that filament gets very, very hot, and you get thermionic emission of electrons from the filament. So basically, you've got a low voltage circuit that's just there to heat up a piece of metal to give off electrons. Then the high voltage part of the circuit is there to accelerate those electrons, and that is then high voltage, and they get accelerated away from the filament and then hit this spot at the end and will cause that to glow. So everything's off, and I'm going to connect up the low voltage circuit first. So this is AC, it's a light bulb, so I'm going into the 0 of the AC, and then on the back of here, need to look carefully because it's not lit up, we've got a negative there, so I'm going to connect it on the negative one, so 0 to negative makes sense. And then the other connection, there's a red connection here that I don't need to use for this setup, and then the other connection I'm going to connect to the 12 volt supply, because that will then make sure that there's a large enough current to heat up the filament. At this point, I can check that's working, so I'm going to turn this all the way down anyway, even though it's not connected. I'll turn on the switches, turn this on, and then what should happen is, if I've got that connected correctly, we should see a light at the end, and you can see there's a light in there, and that is lighting up. So the filament's getting hot, electrons are being released through thermionic emission, but we've got no spot on the end because we're not accelerating it through the high voltage required. So then I need to connect up the high voltage part of the circuit, and this part of the circuit is this connection that I've pointed away from us. So I'm going to use one of these covers. So we have one of these covers, so just so there's no bare metal showing, and I'm going to connect that together like that, so there's no bare metal showing. So I've connected it up like that. You can connect it up the other way around, but I prefer to do it that way around because it looks neater and tidier. And that again is pointed away from anyone, so there's no danger of electric shock. There is a restriction on the amount of current on this, so that if there was an electric shock, it shouldn't be dangerous, but best practice to do everything we can to avoid electric shock anyway. So that then needs to go into the positive 5 kilovolt output. And then the 0, I tend to just connect this back to the same connection that I've got on the back for the low voltage, because 0 is 0 anyway. So now we have a potential difference, and we should be able to get the spot on the end of the tube. So if I turn this on, I've got that turned down, turn this on, the filament should light up. So we should have the filament lit up. There we go, so that's lit up. And then it should just be a case of me increasing the accelerating potential until we get a nice bright spot on the screen, which will be a green spot. So I'm going to turn up the course, and I'll see that the voltage is increasing on here on the kilovolts, it's increasing on there. And once we get, it actually doesn't require very much, but about 1,500, we'll get a pretty clear spot forming on the end. So I can turn that round and angle it so you can see we've got a nice clear spot on the end there. You can keep increasing it, and this is a diffraction. This one is a diffraction beam tube, so you can't see that very clearly on this side. Let's just see if I can turn it around. I may be able to adjust the settings in so that we can see the spot there. We're getting a lot of reflections, but you can actually see the rings much more clearly there. There are two rings. That's not a first and second order diffraction pattern. It's actually a diffraction pattern from the two different spacings within the graphite on the screen. So there's a graphite screen through which we're causing diffraction to happen. And then we've got two different spacings. So there's different spacings depending on the orientation of the crystals. So you've got different spacings in different orientations, which give you these two separate rings. If you look at the voltage, so I've got 3,500 volts, therefore the electrons are 3.5 keV. Then I could measure the spacing of the rings, and I can use that to estimate the spacing of the atoms. That's a way of using diffraction and the beam tube to estimate atomic spacing.